Okie dokie. Alright, so what we can see here is now let's talk about sums of functions and how really that will affect the domain and range of them. So a sum of functions, what it really is just literally just two functions being added together. So when we consider something like x squared plus x, that is already a sum of functions because it's a parabola plus a linear graph. So we actually already know a little bit about sums of functions. Now, where it gets a bit more funky in methods is that sometimes it's not as simple as just not plain polynomial stuff. And you can have like trig and exponentials being mixed together, or trig and exponentials being mixed with polynomials, etc., etc. So what a sum of function is essentially when you've gotten two things conjoined together. It's just like best friends who are a bit inseparable. If one is not defined, the other one is not defined. Just like if one friend is not there, it's unlikely that the other friend, who is very, very close to them and will also not come to wherever the other friend is not, right? So it's kind of works in the same way. They're just like mutually bonded together about whether it's defined or not. So only if both of them are defined will you actually have an overall defined function. Rightio. So we can kind of, by doing that, we can kind of consider the graph we're looking at. So if we look at this number line, and don't underestimate the power of number lines. Number lines are actually really helpful in methods, and it kind of helps you look into like what kind of helps you picture what's going on and what you need to exclude or exclude. Alright, so we can kind of pretend to draw out the domains of a pretend f and a pretend g, because we don't really have functions here. And what we kind of get is that it only has that little section of overlap in the middle. And that little section of overlap is going to be where we get our dom of h from, because it only exists when both of them exist. So before here or after here, it's not actually going to exist anymore. So it's essentially the intersection of the two domains that really gives you the overall domain. Alright, so let's have a further look into our sums of functions. Essentially why it has to work for both functions is because we're going to input it into both functions like this. So if we had, let's say, 1 over x minus 2 and root of 4 minus x, right? What we're going to have here is when 2 gets subbed in, the first one's going to be undefined, but the bottom one is just going to be 2, right? Root 2. So what that actually means to us is that this one does not work and this one does work. So when we kind of reach this pattern here, this one is not defined, so they run from the party, but this one's still here. So because this one's run from the party, it's kind of like an electrical circuit. Now you have a missing part of the circuit because that one's run array. So now you'll no longer be able to generate an appropriate output. Okay, now let's talk about a question on this. Alright, let's talk about questions. So, we have f of x and g of x. And then we are trying to find the maximal domain of the sum of the two functions. So, what we need to find out first is what are the domains of each and how do they work together. So the domain of the first one we can kind of see is negative infinity to 2. Rightio. Okay, so the next domain for g of x, we have negative 2 to infinity, not excluding both. Right? Okay, so then what we're going to get here is that we want something. We can draw a little bit of a number line to kind of consider what we're doing. And we want something from 2 backwards, or we want something from negative 2 onwards. And we can kind of see where the sweet spot is in terms of the terms of which section we want. So that section includes all 3 lines, so we're pretty happy with that, and that's going to just give us what our overall maximal domain is. So then when we do that, we can see that this one we said is 2 and this one we said is -2. So that's 0. Okay, so remember the brackets are also really important. This one was originally a square bracket, so I'm going to just leave it as a square bracket since it's the top one. And then when we look at the other side of it, this one was a round bracket originally, and now it's the smallest part of the function, so we're going to put a round bracket around that. So essentially we'll get option D, -2 to 2.